This video is going to go over graphing transformations in vertex form of quadratics. So when we're talking about transformations of quadratics, we always use vertex form. Now remember, vertex form is y equals a parentheses x minus h squared plus k, where the vertex is the point h comma k. The thing we want to remember about the h is that it's always opposite signs from what it is in the equation, but the k is exactly the same. Now, all of these components have something different to add to transformations. So for example, the a value over here, if a is negative, it opens down. And if it opens down, it's a reflection over the x-axis. You're flipping it from the x-axis, okay? So if it's negative, it opens down. So a negative sign tells us we have a reflection over the x-axis. A also tells us whether we have a vertical stretch or a vertical compression. Narrower, which is a vertical stretch, and I've tried to draw this in the past and try to show you what vertical stretch means, right? If I have a quadratic that looks like this, and I stretch it vertically, stretching it vertically means I'm going to take the vertical axis, which is the y-axis, and I stretch it, so I pull it. If I were to pull that y-axis and pull them apart, my quadratic would get narrower, it would shrink in. But if I were to compress it, if I did a vertical compression, right, a vertical compression, I took my y-axis and I squished it together, then my quadratic would be squished down, right? So it'd be vertical compression. Now we also say this is wider or narrower. So if a is larger than 1, it gets narrower. If a is between 0 and 1, it gets wider. Now I'm not talking about negatives, right, because negatives tells us reflection, so it has nothing to do with the wideness or narrowness of the quadratic. If it's bigger than 1, it gets narrower. Think about it getting taller. So the bigger the number, it gets narrower and skinnier. But if the number is like 1/2 or 1/4 or 0.5, it's going to get wider, okay? Now the next thing is the h. The h tells us whether we're going left or right. So thinking about if you're in the inside of the parentheses, you're going side to side. Inside the parentheses, side to side. So if we're inside, we can either go to the left or we can go to the right. Now it is going to be opposite from what you think. So for example, if I have x plus 3, if I have a positive 3, then that's going to be left 3. Normally when we think of positive, we think of right, but it's opposite. Remember, the h is opposite. And then minus 5 would be to the right 5. And lastly, we have a vertical shift, which means up or down. So the k value will tell us how many units we're going up or how many units we're going down. Now, when we're doing quadratic transformations, we're basing it from the parent function. So the parent function of a quadratic is y equals x squared. Okay, now if you don't remember how to do the square button, it is this button right here. I am tapping it over and over again. This one right here. Okay, so y equals x squared. Okay, so this is the parent function. Now let's go ahead and graph this new function, y equals negative 2, x minus 1 squared plus 2. Go ahead and do that. Y equals negative 2, x minus 1 squared plus 2. And I forgot the x in there. All right, so this is my quadratic. Now notice it is facing opposite from what the parent function is. I'm going to go ahead and show you the parent function again. Now you don't have to graph both, but I am showing you them in comparison. So obviously it has changed a lot. The black is the original parent function, the purple is the new. So obviously there's been a lot of transformations, and now we have to describe it. Before describing it, let's go ahead and graph it. You don't need to graph it in order to describe the transformations. You can actually do the transformations without even graphing it. So let's just change our plans. Let's go ahead and do the transformations first. So I've listed 4 numbers here, which means there are 4 transformations. Okay, and I always like to go left to right. The first thing I notice is this negative sign in the front. Now, what does a negative sign tell me? The negative sign tells me I have a reflection over the x-axis. Okay, so earlier my quadratic was facing up, but when I put that negative in the front, do you see how it's facing down now? Okay, so reflection over the x-axis. And I like to think of the negative sign and then the number to be 2 separate things. So this 2 is going to tell me something completely different from what the negative told me, okay? The negative tells me a reflection. Well, what does the 2 mean? Well, remember, if your a value is bigger than 1, what happens? It gets narrower. If it's between 0 and 1, it gets wider. So for example, I will show you y equals, x squared, right? Oops, my bad. Y equals x squared. So this is the original one, right? Let's go ahead and take the reflection off the purple, which is the transformation. I'm going to go ahead and change this to black so we know that's the original here. Okay, I'm going to go ahead and take off this negative here in the front. The negative obviously flips it, so if I put the negative back on there, it would reflect it over the x-axis. But looking at the purple and the black, what do you notice? The purple is a lot more narrower. What happens if I make that a value even bigger than 1? Make it 6, even more narrow. So do you see how the larger the number, the more narrower it gets? So if it's between 0 and 1, then it gets wider. So because it is 2, it is bigger than 1, it will get narrower. And this is also known as a vertical stretch. Now you don't have to write vertical stretch as well, but it is good information to know. Okay, the next number that I see is the -1. Well, -1's on the inside of the parentheses, and if it's inside, I know it's shifting side to side. The question is it shifting to the left one or to the right one? Now remember when I said if it's inside the h, it's always opposite from what you think. So even though it's a -1, it's actually moving to the right 1 unit. Okay, it's opposite of what you think. If it was +1, then it would be to the left one. Okay, and then lastly, the last thing I noticed is the +2 on the outside. Now that is on the outside, which means it's going to either go up or down. Now if it's up or down, it's going to be exactly what you think, so it's going to be up 2. Okay, so we have 4 transformations here. Let's go ahead and graph this. When I type this into Desmos, right, I have y equals -2x minus 1 squared plus 2. Desmos, if I tap on the graph, it gives me some gray points. Now those gray points are important for me to graph, so I'm going to go ahead and graph those. So I have the point 0, 0. Let's go ahead and graph that one. Okay. The next important point I see is 1, 2. So x, you go to the right one and then up 2, so x direction and then the y direction. And then the last point it gives me is the point 2, 0. So my quadratic looks something like this. That's how you would graph it. I know that you don't all have a graphing calculator at home, so you could just use Desmos and then plot the important points that Desmos sees. So again, transformations, there's make sure you're looking at your A in both directions, right? It's either going to tell you if it's negative or positive, and then it's going to tell you whether it got narrower or wider. If A is equal to 1, then there is no change, so you wouldn't say anything. And again, if you're inside the parentheses, you're moving side to side, left to right, and it is opposite. And the K on the outside means you're going up or down, and it's exactly what you think it is. And that is transformations of quadratics in vertex form.